So what I want to get into today is I want to talk about these, what we call index laws. And I kind of dislike that name because I put laws in quotation marks here because laws just kind of seem like something that are there for whatever reason, they're just made up or someone's just come up with them. But actually I think about them like patterns, these sort of index patterns that exist. And I've got a little bit of a hint here of what we're alluding to. So if I multiply two things, and it's important they have to be the same base, right? I've got two things with the same base and they're multiplied together or divided together. And what's a shortcut way of simplifying that? Let's do this the long way first, and let's use base 2 because I just like using base 2. So let's take 2 squared and then 2 cubed, okay? What do these actually mean? This is where expanded notation comes in handy because when you look at this, right, you actually can understand and unpack what 2 squared and 2 cubed are, right? So 2 squared is 2 times 2. Then I'm multiplying 2 cubed, so 2 times 2 times 2, right? And what does that become? Well, how many 2's do we have here multiplied together? And you can see why they have to be the same base now, because you can put all of these together, and that would be 2 to the power 5, right? So what's the pattern here? Well, if I'm multiplying two things with the same base, what am I doing with the powers? Well, what's the relationship between 2 and 3? 5. Yeah, right, that's the same as 2 plus 3, or 2 to the power 5, right? So, over here, if I have a to the power m times a to the power n, I can write that as a to the power m plus n. If they have the same base and I'm multiplying them, then I can just add the powers there, right? That's our first index law for multiplying. What about dividing? Dividing is a little bit trickier. We can still do it, right? Let's take some other examples. Let's say 2 to the power 6 divided by 2 squared. And again, I'm going to use this expanded notation to explain it, but I think it's more helpful if I look at this in terms of this sort of fractional representation. We know that division and fractions, they can represent the same things, so I'm going to say this is 2 to the power 6, right? So multiplying by itself 6 times, all divided by 2 squared, right? And so you'll notice what happens here is that a lot of things can simplify out, they can divide through. So for example, these 2's will divide through, these 2's would divide through. And it's important to note when I'm dividing them through, I'm not like getting rid of them or anything, like they'll in a sense do that, but what's actually happening is they become 1. So it's really important to note that you actually do have a 1 in the denominator, okay? So that's why this doesn't break or anything, right? So these become 1 essentially, and so the result doesn't change, but what you get left with is over here, 2 times 2 times 2, 2 times 2 times 2 times 2, and it's 2 to the power 4. So what's the relationship there? I've got 6 to the power 6 divided by 2 squared. Now I've got 2 to the power 4. And yeah, that's the same as 6 take away 2, which is 2 to the power 4, right? And so hopefully you get a bit of a hint of that because, if these are these are opposites, if they're multiplying, they're dividing, adding and subtracting come naturally. So this is a to the power m take away n. Okay. Those are our first two index laws for multiplying and dividing.